Namaste. All right, good morning. And today we're going to talk about the concept of acceleration. All right, or in Espanol, acceleración. Yeah, yeah. All right, stay with me. This video is going to be a little bit longer. Make sure you watch it to the end. I know because some of you guys are getting burned by not watching all of my videos to the end. All right, so make sure you are, and make sure you're taking notes on what I'm saying. Okay? All right, because we're going to high school it up a little bit. A lot of you guys have learned in the elementary school or the middle school that acceleration means speed. It doesn't. And in fact, you guys aren't alone. Most Americans screw that up. Okay, and when they say the word acceleration to accelerate, I'm accelerating really fast, and they think that it automatically means that you're going really fast. That's not always the case. Okay, so I'm going to high school it up for you, and I'm going to give you the real definition and the real meaning of the word acceleration. Okay, so what it is acceleration is any change in velocity. Okay, it's any change in velocity. All right, so here's what I mean by it. Well, one, let's first get the word down. So acceleration is any change in velocity. Okay, and I'm going to underline the word velocity because that's important. It's velocity, not speed. And remember, velocity and speed are slightly different things. Speed is just a number, it's how fast you're going. Velocity is how fast you're going with a direction. It's a vector. It's a vector quantity. So that's important here because you're going to find out, and I'm about to teach you right now, there are three ways that you can accelerate, okay? And the first way is what everybody thinks. So the first way is speeding up. And we call this a positive acceleration. Okay? Because obviously if you're speeding up, you're changing through speed. You're going from a slower speed to a higher speed, and so obviously you're changing. Okay? Number two could be the opposite. You could be slowing down. Okay? And we call this a negative acceleration. Okay? And why is slowing down an acceleration? Well, because the definition is it's any change. If you're slowing down, if you're going from a faster speed to a slower speed, like when you hit the brakes on your car, you're changing velocities. So therefore you're accelerating. We just call that a negative acceleration. Now the third way is a little bit different because velocity is a vector. There are several things you could change about it. You could change its magnitude, its size. You could speed up or slow down. This is changing the size of your velocity. But because velocity is a vector, it has a direction to it, you could also change its direction. So the third way to accelerate is to turn. Okay? And we have a special name for that. We call this a centripetal. Centripetal acceleration, and the word is centripetal. Notice the way I'm saying it, centripetal, okay? Not centrifugal or centrifugal or something like that, because a lot of people see that, well, and they think they know what they're talking about, and they see like a little whirlwind outside in the fall and it makes the leaves go around or something, or they see the water going down the drain and it turns like, oh, what is that? And they'll act like they know what they're talking about, and it's like, well, that's some sort of centrifugal, except shut up. You don't know what you're talking about. The word is centripetal, and the word actually means center seeking. Okay? And you might want to write that down because, hint, in case you see it on a Google form or something like that. Hint. All right? So the word means center seeking, all right, in Latin, I believe. All right, so anywho, those are the three ways that you can accelerate. You could either speed up, slow down, or you can turn. All right? Okay. Let me talk about let me talk about the units on it, and I'm going to draw a little picture here, okay? And good, you can still see that on the board. So let's say what happens when you fall, all right? Or if you drop something. What happens if you drop something? Well, it accelerates. Why? Because there's this force called gravity, and gravity makes things accelerate, makes things speed up towards the center of the earth. And so let's say that, now check this out. Let's say that here's a ball, and it's going to fall down some high cliff or something like that. And here it is at time equals 0 seconds, okay? And it has 0 velocity, so its velocity is 0 meters per second, okay? Well, let's time this thing. Let's look at this. Let's take snapshots of this thing as it falls. All right, so here's the ball, let's say 1 second later, okay? So t is 1 second. What's its velocity? Well, on Earth, the magic number for acceleration on Earth is 9.8 in the metric system, 9.8 meters per second squared. Notice I said per second squared. I'm going to explain that in a second. So its velocity is 9.8 meters per second, all right? And now, what's going on with that? Does it stay at 9.8 meters per second? No. In fact, how long is it at 9.8 meters per second? Only an instant in time, an infinitely small instant in time. Acceleration means that you're passing through speeds. You're not at any one speed for any length of time. In fact, between here and here, how many speeds did you pass through? Actually, an infinite number of speeds. And I know that's kind of big for you guys, all right, because you're not used to the concept yet of infinity. Between 0 and 9.8, there's an infinite amount of speeds. There's 1 meter per second, there's 2 meters per second, 3 meters per second, but there's also 1.1 meter per second, 1.11 meters per second, 1.1111 meters per second. There's an infinite number of speeds in between 0 and 9.8. And it's not going to stay at 9.8. It's going to get faster, neglecting air resistance, and we're not taking into account that right now. So let's look at it. Here's another second later, and it's down here. Notice this is further. Why? Because it's traveling faster. It's getting faster, so it covers more ground in each successive second. So here we are at t is equal to 2 seconds. What's its velocity now? Well, it sped up. On Earth, it's sped up by 9.8 meters per second every second. So it gained another 9.8 meters per second of speed. So its speed is 9.8 meters per second plus 9.8 again meters per second, which is 19.6 meters per second. So its speed at 2 seconds after it falls is 19.6 meters per second. It gained another 9.8. Now check it out. Here it is at second number 3, and note it's a little bit farther, all right? So what's its speed? So here we are, t is 3 seconds. What's its velocity? I'm sorry, I keep using speed. What's its velocity at this point? Well, if this is 9.8 plus 9.8, if you look at the pattern, starting at 0, you have no speed, no velocity. Starting at 1 second, you're passing through 9.8. At 2 seconds, you're passing through 2 times 9.8. At 3 seconds, you're passing through 3 times 9.8. 9.8 plus 9.8 plus, you gained another 9.8 meters per second, or that's 3 times 9.8, okay? And that would be, I worked it out, that would be 29.4 meters per second. So it keeps gaining, let me give you a little more board space there. So it keeps gaining speed at a rate of, it gains another 9.8 meters per second of velocity after each second that it falls. So after 4 seconds, it would be, what would its velocity be? It would be 4 times 9.8. After 5 seconds, it would be 5 times 9.8, okay? And that's how you figure it out, okay? And so if you notice, you're gaining speed. I gotta erase this because I need the board space. You're gaining speed at a rate of 9.8 meters per second every second. Notice how I did that. So instead of writing per second, we write 9.8 meters per second squared is the code. That's how we write that. All right, that means per second per second. Okay, so that's not a velocity. That's a change in velocity. That's how fast you're changing velocity. On the moon, your acceleration due to gravity is 1.6 meters per second squared. What does that mean? That means for the same thing, object falling on the moon, you would start at 0. 1 second later, it'd be passing through 1.6 meters per second. The second it fall, it'd be passing through 2 times 1.6. Third second, 3 times 1.6, and so on. And that's what that means, okay? So, but on Earth, the acceleration due to gravity is 9.8 meters per second. And because it's such a special acceleration, we give it a special letter. We give it a small letter G for acceleration due to gravity. On Earth is 9.8 meters per second squared. I want you to memorize that. I don't ask you to memorize a lot, but I do want you to memorize that. On Earth, the acceleration due to gravity is 9.8 meters per second squared, and it has, in the English system, that's 32 feet per second squared. Okay? So I want you to memorize that. All right, okay. How do you calculate acceleration? Well, it's a change in velocity, so the way we do that is this. An object's acceleration is equal to, now look at the code here. Its final velocity, I'm going to put a little F for final, write that down if you're going to forget, minus its initial velocity divided by time, okay? And that's how you calculate it. So I'm going to do an example, and I have some calculated right now, so check it out. So let's say that an object is starting at, let me get my notes here, is starting at 3 meters per second. So let's say I have an object that, let's say you're on a bike and you're moving at 3 meters per second, and then some dog comes out of someone's yard and they start chasing you. So what do? You speed up to get away from it. And so here you are sometime later, and you're going 9 meters per second because you sped up, and it took you 3 seconds to speed up from 3 to 9. What's your acceleration? Well, your acceleration would be, okay, now your final velocity would be 9, so 9 meters per second, that's your final velocity, minus 3 meters per second, that's your initial velocity, 3 meters per second, and you did it in a time of 3 seconds, so 3 seconds. So 9 minus 3 is 6 meters per second divided by 3 seconds. The seconds cancel, actually the seconds do not cancel out, sorry, second. All right, and this gives you 6 divided by 3 is 2 meters per second squared. So you got faster at a rate of 2 meters per second every second that you were speeding up. This is how much you got faster by, okay? So let me give you another example, and I'm going to mess with this equation because you can, let's say that someone gives, you know your acceleration, you know your final initial velocities, and someone asks you, how long does it take you to speed up to a certain speed? Okay? How long does it take you to speed up to a certain speed? All right? Well, what you would do is this. You would take the equation and rearrange it. All right? And so you would take this equation, I'm going to leave it up there, and if you rearrange it to solve, and I'm using the word solve because your math teachers taught you algebra, and they taught you to solve for x or solve for y. If you were to solve for t and rearrange this equation, you would get vf minus vi divided by a. This is, use this if you get a problem that asks for how long. How long in terms of time, okay? So that's, you would use this version. Write this down and write this down and write how long in your notes, because I'm going to give you guys some problems, some word problems, okay? They're not going to be hard. You can do them, and I'm showing you how to do them right now, so just kind of keep up with me. So let's say, for example, that you're starting from rest, and you're going to speed up to 8 meters per second, and you're going to accelerate at 2 meters per second. How long does it take you to get to 8 meters per second? So here you are on your bike, and you're going to start from rest. If you see the word start from rest, that means your initial velocity, VI, is 0. Okay? And it doesn't really matter what, miles per hour, meters per second, 0 is 0. Okay? And you're going to speed up to 8 meters per second. That's your final velocity. That's your VF. And you're going to do it with an acceleration of 2 meters per second squared. Okay? All right. And how long does it take you to do that? Well, I'm going to plug it into this. So T is equal to VF is 8 meters per second minus, what's your VI? 0. That's nice. That makes it easy. 8 minus 0 is just 8. Divided by your acceleration, which is 2 meters per second squared. And we're using easy numbers here. I'm seeing if I'm trying to teach you how to use these equations. I don't want to get all that complex. So 8 minus 0 is just 8 meters per second divided by 2 meters per second squared. 8 divided by 2 is 4. The meters cancel. That seconds goes with one of the seconds there, and it gives you 4 seconds. So if you're starting from 0, you accelerate at 2 meters per, you speed up at 2 meters per second every second. It takes you 4 seconds to speed up to 8 meters per second. And that's how I did that. Okay? Again, see me with questions during office hours. All right. I'm going to do one last version of this. All right? So I got to erase this because I need the board space. All right. So let's say that someone asks you this question. And they say, okay, so here you are, and you're on your bike, and you're going 2 meters per second. So your initial velocity is 2 meters per second. And you're speeding up at a rate of 3 meters per second squared. So you're getting faster by 3 meters per second every second, okay? And you're going to do this for a time of, you're going to speed up for 4 seconds. Make sure I got that right because I got it worked out. How fast are you going after 4 seconds? And notice how I worded that. How fast are you going after 4 seconds? Okay? Well, watch how I do this. If I take this equation and I rearrange it, okay, to solve for the final velocity, I would get something like this. VF is equal to, okay, VI, and trust me, obviously I'm skipping steps on the algebra, but just trust me on it. VI, okay, plus A times T. This and this are really the same equation, they're just rearranged. In this case, it's arranged to have A on one side, everything else on the other. In this case, it's arranged to have VF on one side and everything else on the other. But they're really the same equation, okay? So, and again, so if someone asks you how fast, right, how fast, okay, you would use this version of the equation. So look for that in the word problems when I say how fast is the object going. Okay, so if you're starting at 2 and you're speeding up at 3 meters per second squared, and you do that for 4 seconds, you pedal faster and faster for 4 seconds, how fast will you finally be going after those 4 seconds? Well, it's pretty easy. It's, okay, so your initial speed, VI, is 2 meters per second, plus your A is 3 meters per second squared, times a time of 4 seconds. Okay, so this is the same as 2 meters per second plus 3 times 4 is 12. Let me do that. You see that? A little bit of a glare there. 12 meters per second. Okay. 2 plus 12 is 14 meters per second. Okay. So if I start at 2 and I speed up at 3 meters per second squared and I do that for 4 seconds, at the end, my final speed after 4 seconds will be 14 meters per second. Now I know this sounds like math and you're like, this isn't a math class. It sort of is. Science, it's not a math class per se, but understand, and you need to learn this now. This is not an elementary school. This is not a middle school. This is a high school. So let me teach you this. Science uses math. Period. Science uses math. Why? Because you can't argue with math. That's what makes it so powerful, and that's what makes science so powerful, all right, as a method, okay? Because it uses math. That's a tradition started 300 years ago by Isaac Newton, okay? Actually, it goes even further back to Galileo, all right? But there you go. Okay, so that's the basics of acceleration. Come and see me during my office hours because I know I'm going to have some questions from you guys on this, okay? And I know the video was a little bit longer, but just kind of bear with it. Oh, and remember this, 42. $42. $42 is the answer to life, the universe, and everything. Just saying. Okay, so, all right, check it out. Get to work on these things and see me during office hours, all right? So, goal is out and enjoy your apocalypse. I know I am.